Welcome to the first video of my YouTube channel. Today we will be diving into the world of brewing, focusing on brewing equipment and its practical applications. In this video, I'll be sharing the modifications I've made to my Brewzilla 65-liter Gen 4 brewing system, specifically to enable automated mash mixing. This system stood out to me as it was one of the first all-in-one home brewing systems without the center standpipe, allowing for automated mash mixing with a motor continuously stirring the mash. Throughout the video, we'll cover an overview of the components I've applied, testing of the modified system, issues I've encountered along the way, and finally, I'll share my concluding thoughts and consideration. I want to emphasize that this video is not sponsored, and all the pieces and parts have been purchased with my own money. The cornerstone of this system is the agitator for mashing 75, produced from Polsinelli in Italy. Originally designed for their brewing pots, this agitator proved to be an excellent foundation, featuring a robust motor, shaft, and mixing blades. With minimal adjustments, it can be integrated with the Brewzilla. For more details and where to find this component, please refer to the link provided above the video or in the video description. On the left side, the modified agitator is showcased. To integrate it with the Brewzilla, the metal plate was cut to the correct diameter, a metal ring was welded to the plate, along with small metal pieces for the clamps to securely hold onto. Additionally, a 1.5-inch tri-clamp port for recirculation was incorporated. Notably, one of the metal pins was positioned to ensure that once the clamp latching onto this pin is closed, it secures and stabilizes the lid, preventing any potential vibrations. On the right side, you can observe one of the initial tests of the system. In order to facilitate heat distribution from the bottom of the brewing system to the top, a series of components were assembled in the specific order shown on the right. The Kegland wrapped Bluetooth thermometer, typically intended for placement in the middle of the mash, was situated within the wort stream as part of the circulation process, as the mash mixing blades made its regular placement impossible. This allowed for precise temperature control of the wort just before it was reintroduced on top of the grist. To incorporate the temperature probe into the circulation loop, a compression gland for thermocouple with half-inch NPT thread and a small EPDM O-ring were utilized. A link to the O-ring can be found in the video description. As a compression gland in the correct size for the Bluetooth thermometer was unavailable, the mounting hole was altered using a 3.9mm drill bit. In addition to the digital thermometer, an analog thermometer was incorporated as a control measure. Both thermometers, along with the wort stream from the brew system's recirculation arm via the Kegland flexi arm, were connected via a half-inch NPT cross fitting. This cross fitting was then securely mounted on a tri-clamp fitting with half-inch male NPT fittings on each side. The side entering the pot was equipped with a SS Brewtech whirlpool fitting to evenly disperse the wort stream over the top of the grist. The effect of the whirlpool fitting can be seen on the image to the right. All fittings were made from stainless steel and connected using quick connect fittings, ensuring effortless disassembly and cleaning. The entire assembly was mounted on the Brewzilla, utilizing the silicone gasket designed for the boiler extension. In addition to the modification for mash mixing, I opted to upgrade the original pump with the more powerful 25-watt pump from Kegland. While there are numerous tutorials on YouTube detailing this process, a common issue arises in all of them. The placement of the pump causes a kink in the silicone hose at the outlet when connecting directly to the pump. To address this challenge without resorting to cutting parts of the pump, and to enable direct bypassing of the pump leading straight to the bottom valve, I devised the setup shown on the screen. In addition to the existing hoses and clamps, I incorporated a John Guest straight hose adapter, a small piece of silicone tubing, and two hose connector clamps. Ultimately, my plan is to replace the plastic John Guest fitting with a stainless steel equivalent. I trust that this setup can provide assistance or inspiration to others seeking to undertake this pump upgrade while opting for a bypass solution. The final modification I made to the system was to insert 4 bolts around the edge of the malt pipe to ensure the malt pipe would not rotate due to the mixing. An image of one of the bolts can be seen on the right. After conducting initial tests with the new mixing system, I observed a significant increase in efficiency, prompting adjustments to several of my recipes. While my efficiency with periodic manual stirring averaged around 70 to 75%, the continuous automatic stirring elevated it to 85 to 90%. This enhanced efficiency has allowed for better utilization of the malt, enabling me, if needed, to transition to a 2-to-1 water to grist ratio without the efficiency dropping below 70%. However, for these larger quantities of malt, the stirring must remain active during the malt addition and cannot be stopped before the mashing process is completed, as the motor lacks the necessary power to restart once the malt has settled. This improvement has facilitated the production of high ABV brews without the need for double mashing or omitting sparging, with the highest attempted single mash resulting in a 16% ABV Imperial Stout. Additionally, the mixing system has proven beneficial for pH adjustments, allowing for reliable pH measurements just 10 minutes after adding the malt and quicker equilibration following the addition of lactic acid. Moreover, the continuous mixing has positively impacted temperature control, leading to more uniform temperatures across the mash and faster propagation of temperature changes throughout. In summary, I am thoroughly pleased with the automated mixing system and the positive impact it has had on my brewing process. The automated stirring, though a bit noisy as can be heard in the video, offers the advantage of not requiring constant supervision, making it manageable despite the noise. However, the highly efficient mashing and continuous stirring lead to a compact malt bed, resulting in longer lautering times even with the addition of rice hulls. To address this, I manually stir up the malt bed post mash out and repack the grist bed at a slow pump speed. After transitioning to automated mixing, I encountered an issue where small particles passed through the false bottom of the malt pipe, causing blockages and low flow in the lower false bottom or heat exchanger dish, leading to potential scorching of the mash. Omitting the heat exchanger dish and delaying the addition of the lower false bottom until lautering is completed has proven to work best alongside repacking the grist bed to catch smaller particles on top without compromising wort clarity. The image to the right shows an example of the particles that have passed through and have been caught in a kitchen strainer. The combination of these changes and the repacking of the grist bed leads to the capture of smaller, fine particles on top of the grist bed. Please refer to the image on the right displaying the malt bed post-lautering and sparging. However, the sinking of these small particles onto the top of the grist bed during lautering can lead to a slow or stuck sparge. The solution to the issue is to gently stir the top 2 to 4 centimeters of the malt bed to resuspend the particles, thereby accelerating lautering and sparging without compromising wort clarity. Finally, small channels forming to the perforated side part of the malt pipe have caused wort to spray out over the side of the brewing equipment. I have not found a solution beyond catching and pouring back the wort. I suggest that future iterations of the Brewzilla brewing equipment could position the malt pipe so the perforated part is situated just below the outer edge when the malt pipe is at the top position to mitigate this issue. All in all, I see these as minor issues, and even though they slightly prolong the brew day, the increase in efficiency greatly outweigh these workarounds and solutions that I've had to implement. Thank you for watching. If you enjoyed the video, please consider liking and subscribing.